Hello everybody. Today we are going to see from the components of case 10.3. We had completed till here. Before, check your progress 1 and let's start from here. The 10.3 components of case. The activity that can be automated, whether partially or fully, depends on the case tools that are used. Most of the case tools generate a working model or prototype, which makes development process faster and easier. Types of case tools. The following are various types of case tools. Planning and management tools begin the development process with information, planning and project management. Analysis tools. These tools ensure that business requirements are correctly captured during the analysis phase early in the development process. Analysis tools are used to check for incomplete, inconsistent, or incorrect specifications. Design tool set. It provides detailed specification of the system. Information integrator it integrates system specifications and checks them for consistency and completeness. It also records them in the case repository. Code generator. It automatically generates code specification specific to a language based on the system specification. Database design toolset. It suggests database design and generates system control information. User interface generator. It generates user interface based on system specification. Report generator. It generates reports based on specification. Now here we can see figure 10.1 depicts various components of a typical case tool. So here we can see the diagram, and yes, components of a typical case tool. All case tools are based on prototyping, which is particularly useful when the user requirements are difficult to define. Large systems use traditional SDLC approach, but part of the system can be prototyped. The prototype is then repeatedly refined till it becomes acceptable. Classification of case tools. Figure 10.2 depicts various types of case tools. Although case tools can be classified depending on the functionalities, these can be broadly classified into 5 generic categories. Development tools. These tools are interactive in nature. They are used for design support and code generation. Front-end tools. They support activities early in the life cycle of a software development process. Planning, analysis, and design. Examples are data flow diagram, data structure diagram, ER diagram, prototyping tools, etc. Backend tools. They support activities later in the life cycle of a software development process. Implementation and maintenance. Examples are program flowchart, program editor, debugger, code generators, etc. Horizontal tools. These tools are not specific to a particular life cycle step but are common across a number of life cycle steps. Example, a documentation tool. Vertical tools. These tools are specific to a life cycle. Case repository like business system planning, project management, analysis, design, programming, prototyping, integration and testing, re engineering. Okay, 10.2 types of case tools. Okay, figure 10.2. Reverse and forward engineering. We will discuss two important concepts related to case tools, namely forward engineering and reverse engineering. Figure 10.3 depicts both forward and reverse engineering. Reverse engineering is the process of recreation of model based on existing code. First, the existing code is scanned to generate the model. Then the model can be fine-tuned in accordance with requirements. Reverse engineering allows developers to create model for old systems which were never modeled. It analyzes existing software with purpose of understanding its design and specification. Reverse engineering tools read program source code and create graphical and textual representation of design. Forward engineering is a process of generation of skeleton code out of the models. First step is to create the model for a system, then generate the relevant code for the model, and then allow modification of this code in tune with the requirements. Re-engineering means restructuring and rewriting the legacy system or part of it without changing its original functionality. Re-engineering efforts makes the software up to date to current technology and hence easy to maintain. The new system becomes restructured and redocumented. Re-engineering tools read program source code and interactively change an existing system to improve quality, performance, or maintainability. So here we can see more design issues and case tools. Figure 10.3, reverse engineering and forward engineering. Check your progress too. Okay, so yes, check your progress too. Answers will be available soon in the description, so check that out. And the next lecture will start from visual and emerging case tools 10.2. So thank you and keep exploring.